Hello everyone and welcome to Selective Preparation Power Thinking Skills Test 16. So in this video, as per usual, we have 10 questions to go through. Let's start with the first one. So first question, we have 4 green marbles and 3 blue marbles, and then 2 students are asked by the probability that 2 green marbles are pulled one after another. So when we have probability of 2 events happening one after another, these probabilities are linked. Okay, so the first marble has to be green, and then the second one must also be green. If either of these are not green, then we have not calculated the correct probability. So let's see. First of all, what is the chance of our first marble being green? Well, there are 4 green marbles out of a total of 7 marbles in the bag. So the first one would be 4 out of 7. Now, given that this first one is green, because we only want to see when they're both green, right? We already know that the first one is green. So the second one, what is the chance of it being green? Well, there are only 3 green marbles left in the bag because we already took one for the first one, and there will be a total of 6 marbles now because one has already been taken out. To find this probability, we have to multiply to make sure that the first and second probabilities are linked. When we do that, 4 times 3 is 12, 7 times 6 is 42. We can simplify this, divide top and bottom by 2. 6 over 21, divide top and bottom by 3, 2 over 7. Now let's read. Zach says the probability is 16 over 49 because there's a 4 out of 7 chance of pulling out a green marble. He's wrong. Remember, our probability of the second one is removing 1 already. Okay, so that's why it's wrong. So he says probability is 2 over 7. Second marble is harder to pick correctly than the first. That's correct. 4 out of 7 is a little more than half. 3 out of 6 is half. So it is definitely harder to pick out the second marble. And when you multiply it, you get 2 out of 7, which Zoe has said. So using that logic, we can see that the answer here is B. Only Zoe is correct. Okay, number 2. So we have a statement. It says that much research shows that teenagers are likely to speed while driving and to crash. We know that adults over 25 are not teenagers, so we can conclude that adults over 25 are not likely to speed while driving and to crash. So what we have done is just because these people, adults, don't belong in this group that we've tested, we have concluded that because they aren't in this group, they won't crash. Now that is not true, okay? Just because adults don't belong in this group doesn't mean that they automatically won't crash. They won't do the things that this group does. So the best answer here is D. The argument assumes that because adults are not teenagers, they do not speed. Because adults are not teenagers, right? That's the reason behind this argument, and that is a flaw. Okay, we don't know any testing about adults in specific. We don't have any information about adults. We have just concluded that because they're not teenagers, they're automatically exempt from crashing, which is not true. Okay, number 3. So Operation Barbarossa, codename, we know that it describes the invasion of the Soviet Union by Nazi Germany. The operation dragged out into the winter, and it is this length that is most attributed to Germany's loss, given their lack of preparation for the freezing Russian winter. So we know that the main reason why the Germans lost was because it was winter and they were not prepared for the freezing Russian winter. What would strengthen this? If we had an argument that showed that Germany lost because of this winter that they weren't prepared for, then that would strengthen it. And the answer therefore is B. The Soviet military were well adjusted to fighting in very cold conditions. Now this links to the coldness of the Russian winter, and it also shows why the Germans lost or why the Soviets won, because they were well accustomed, which is the opposite of not being prepared. Okay, number 4. So we have a little statement about minimalism. It is a movement in art that is unique for its use of extreme simplicity to capture emotions and ideas in art. It forms as a rejection of previous movements, and they have some features like geometric structures that abstractly correct the idea. So what is it saying? Before this minimalism came about, there were some other previous art movements, and we were rejecting that, which means we are casting it aside, making room for something new. That means that in the past, these previous movements were not minimalistic. They were not simple. So what would best support that? The answer is B. Older movements or previous movements used more complex forms to represent their ideas. Complex is the opposite of simple, right? It's the opposite of simple. So it makes sense that we rejected these movements to bring about this simplicity. Okay, number 5. So a particular disease is known to occur in 1% of the human population. Particular test for this disease returns a positive test for the disease in 1% of all humans tested. Jack says this test must be very accurate because it detects every case of the disease correctly. Is he correct or not? Jack is actually incorrect. Just because we know it occurs in 1% of the human population, let's say 1 in 100. If there was 100 people in this world, 1 will get this disease. Now, this test will return a positive test for 1% of all humans tested. Let's say 100 people are tested, 1 in 100 will return a positive test. Now, you might say, well, these numbers are the same, so this must be an accurate test. That is incorrect. We don't know if this 1 in 100 person actually has the disease or doesn't have the disease. We just know that it's a positive result. Remember, our results are positive. It doesn't mean that the person has a disease, okay? It could be a false positive, which means that it detects, it says that they have the disease, but they actually don't. In that case, this test would not be accurate. Just because these two numbers look the same doesn't mean we have tested correctly for the person who got the disease. Jill says this test must be very accurate because it reported the number of cases of the disease that we expected. Now, it did report the number of cases that we expected, but like we said, the test is not accurate because we don't know if this one person actually has a disease or not. So, neither Jack nor Jill are correct, so the answer is D. Okay, number 6, we are comparing these two cars. There are some things that we have to compare, right? We have car A and car B. So we have fuel efficiency and we have positive rating. That's just a plus with a VE, which means positive, okay? The fuel efficiency for A is 8 liters per 100, and this one is 12.5 kilometers per liter of fuel. So we know that there's 12.5 kilometers per liter. Let's try and make this per liter. 100 kilometers for 8 liters. So 1 liter, you divide both sides by 8. Divide this by 8, you get 12.5 kilometers. 12.5 kilometers per liter for car A as well. So that means that the fuel efficiency is the same, so we actually can't use this to compare. We have to use the other thing. 15 out of 18 people here rated positively. 3 out of 12 rated negatively. So that means the other people must be positive, so it's 9 out of 12. If I simplify, this will give me 3/4, which is 75%. 15 over 18, we can divide. 0. Let's try 8. 8 is 64. 144. And then there's 6 out of 0. 3, and so on, which is around 83%. You can now clearly see that car A has a better positive rating, which means that it is the better car. So that's why you can choose option B, because it is rated more positively. Okay, identifying the assumption. So in a particular city, there has been an intersection that is labeled accident prone. Therefore, the city council decides to install a red light speed camera to make this intersection safer, and they will basically watch any driver who runs a red light or driving over the speed limit. What is the assumption? The assumption is that just by installing a red light speed camera, this area will no longer have accidents. There is no statement that shows in this paragraph the accidents are due to speeding or due to running a red light. That's why the answer is C, okay? That the intersection is unsafe because people are speeding or running red lights. That is our assumption. It might be a different thing. There might be trees in the way that prevents people from looking carefully, or maybe the roads are constructed not that well, so then the roads are bumpy. There are other stuff that it could be, and just by putting a red light camera there may not decrease the accident rate. That's why C is the answer here. Number 8, Donna is 6 years older than Bill. Okay, Donna is 6 years older than Bill. Bill is 5 years younger than Jenny, who will be 17 next year. So Jenny right now is 60, right? Bill is 5 years younger than Jenny. So Bill must be 16 minus 5, which is 11. Donna is 6 years older than Bill, so that's 11 plus 6 is 17. So Jenny sits right there. Which one must be true? Jenny is 1 year younger than Donna. Jenny is 1 year younger than Donna. Yes, correct. A is the correct answer. You can check B. Jenny and Donna are the same age. No, they're not. Bill will be 11 next year. Nope, he's 11 this year. And Jenny is 1 year older than Donna. No, Donna is 1 year older than Jenny. Okay. Question 9. Okay, so let's highlight the main kind of argument. The Olympic is international sports, and it has high caliber of participants, which means they're very elite. The people who participate are the best of the best. And the history of the games, and the publicity, which means how much attention it gets. It is a highly coveted event. Highly coveted means that it is very popular, okay? Very popular, and it's very prestigious, which means that it is highly regarded. Everyone thinks that it's a very good event. So what is the best supported argument? It's B. And our last question for today. These 3 dice are identical. What number is at the bottom of the dice? So you're actually very lucky here because all they've done is rotated it around the dice like this. They haven't actually changed the way that the dice is sitting. You can see that by looking at this last one, 4, 3, 1. Okay, this 4, 3, 1 here. The 3 is in the front in this second one. This first one, sorry. The 3 is in the front, so we've basically turned it this way. So the 4 must be sitting on this side here. Now, if the 4 is there, then the back here must be 6 because the 6 is here, the 4 is there. So by relation, the 6 must be at the back. So we have all the numbers except 5, which means that 5 actually sits on the base for all of these die. So what is the number at the bottom? The answer is C. Okay, some key points from this test. First of all, for understanding people questions. Try and examine each of the arguments made by the people carefully. Okay, what is their main argument and what is their reasoning? If their reasoning is incorrect, then their whole argument is also not correct. So sometimes they do make these questions where the argument is correct, but then the reasoning behind it is not correct. That doesn't mean that their whole thing is correct, okay? Please be careful about that. Alright, that's it for today. Hope you guys enjoyed that video, and I will see you in the next video.